Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hi, today in my bench I have two camera battery chargers. Now the first one, as you can see, it is branded and it is made by Sony and it has a model number of bc-v615 and it is made in Japan as it is written in the label in here. The second one, it doesn't have a brand name or a model number, but it has a spec. It is written and printed in this label and it is made in China. Now, according to the owner, he was using both of these and suddenly they stopped working. So today in this video we are going to tear these two chargers apart and see what it is wrong in them and how we are going to fix them. So let's get started. So I started with the Sony charger, and in order you can open this model up and tear it down, you have to remove 3 screws from this side, and also this side, and they are buried under the label. So yeah, once you remove these 3 screws from their places, you can open the cover or the body or the enclosure of the charger. So let me put the back cover of the charger aside and take a look at the PC board. Now, if we take a look at the PC board, you can clearly see how cheaply it is made. And there is absolutely no clearance between the primary side or the live side of the power rails and the output. So yeah, this type of charger, it is really cheaply made, and if this thing it is made in Japan, then I'm Captain America. So yeah, and if we just flip the board or the PC board to the other side, you can clearly see that it doesn't even have a bridge diode and it doesn't even have a IC. It has a transistor, a switching transistor, and it has a control transistor for controlling the switching transistor. So yeah, and it doesn't even have a photocopier IC. So this thing, it is made just to work. Wow. Anyway, what I'm going to do, I'm going to test all of these components and see what it is wrong or what it is faulty and replace it, and we will hope that this charger will work again. So I'm going to test them and then I will see what I will come up with. So I desoldered all of the components from their places in the PC board, and once I remove all of these, I tested each component individually using the VOM meter and also the capacitor meter. And after I perform these tests, it turns out that these 4 components are the faulty ones. So if we take a look at this guy over here, and this is, as you can see, the main filter capacitor, and it has a capacitance of 2.2 microfarad and it can handle up to 400 volts. And the curious thing that there is no noticeable damage in the body of the capacitor, but if we tested it using the capacitor meter, we can see that it is long gone. And also the shopper transistor power supply capacitor, it is also gone. And we have this 1 watt 1 ohm resistor that act like a fuse in the circuit, it is also burnt. So they don't use a normal fuse in this circuit, they use a resistor. Wow. And we have at last this small SMD transistor that drive and control the main shopper transistor. It is wide open. So yeah, I must say this is one of the cheapest type of switch mode power supply or power circuit or whatever you want to call it that I ever seen, and I am very curious to reverse engineer this thing just to see how they made it and what make it work. So I'm going to draw that circuit and I will be back. So here is the schematic of this charger circuit, and we can see that it is a very simple circuit, and it is basically an oscillator circuit that the only purpose of it is to drive this shopper transistor. And this circuit, it uses a normal transistor, it doesn't use a MOSFET. So yeah. Now after I studied all of the component and how they wire it, actually this is a switch mode version of a normal step down transformer. But there is two major differences between a normal step down transformer and this one. First of all, the size, and we all know that if we want a 800 milliamp or a 600 milliamp from a transformer, the iron core of that transformer or a step down transformer will be big, and also the cost of a normal step down transformer will be up to 20 or maybe 100 of this entire charger. So yeah, and especially if it was a really high quality. And this circuit, it is superior to the step down transformer by another thing, that this thing can work on a wide range of voltages from 100 to 240. While the step down or the normal step down transformer, you have to use a selector switch, and also you can select what type of voltages, what type of grid voltage you have in your area. So yeah, but yeah, this is a cheap circuit, and its only purpose is just to work. It doesn't handle any kind of abuse from the main power grid voltage, and it doesn't handle a lot of stress or pressure from the user or from the in the output of it. So yeah, wow. Anyway, I'm going now to connect some power to this unit or to this circuit board and see if this charger will work right or not. So I connected the charger to my AC power plug, and also I turned on my DMM, and I connected the negative lead of my DMM to the negative trace in the output of this charger. And now I'm going to plug in the power, and we will see how this charger will work. As we can see, once I plugged in the power, the red LED, it is light up, and that is a really good indication that the charger, it is working. Now the other LED, it is supposed to be and must to be off, and that is because there is no battery. It is connected to the charging port of this charger. So if we examine and see the output of this charger, and we can see that it is 9.9 volts, so it is about 10 volts, and we can see if we examine, this is the positive, and this is the output of the charging ports, and we get a 8.229, so it is an 8.3 or close to 8.3 volts, and that is completely normal, and that is compatible with the specs that it is written in the label. So I believe we have a working charger, and all what I have to do now is re-secure this board into its place and re-secure all of the screws to their places, and this charger, it is done. And we will take a look at the other charger. So here is the other charger has been opened, and in order you can open this model of charger, you have to dig out two screws. They are buried under the label, and once you dig them out, you can unscrew them and you can remove the back cover of this charger. Now, one thing caught my attention while I was tearing down this charger. This charger has this flip type AC plug. So yeah, I don't like this model, and this model, in my opinion, it is very gimmicky, and it can break if it mishandled right. So yeah, but I'm not going to make any change in that or in this matter. I will leave it as it is as long it is working. Now, taking a look at the PCB of this charger, we can clearly see that this charger, it is much more higher grade than the Sony ones, because of three obvious reasons. First of all, this thing uses a full or a legit IC in order so it can drive the chopper transformer, and also this thing uses a full bridge diode in order so it can convert the power grid voltage into DC, and also the clearance between the primary side and the secondary side of the power rails, as you can see. So yeah, so this is a really good type of charger in regard of these three manners, and it is much more superior and safer to use than the Sony ones. So yeah, but if we flip the board into the other side, we can see that it is almost very similar to the Sony charger, and it doesn't also use a fuse, it uses a resistor. So yeah, and there is a fourth thing that it is, or the fourth thing that it is superior than the Sony. This charger uses a 2 amp rectifier diode in the output, while the Sony, it uses a 1 amp. So yeah. Now, after I examined the PC board, I couldn't find any faulty component. So what I'm going to do, I will test every component using the VOM and also the capacitor meter, and we will see what it is wrong in this charger and how we can fix it. So I tested all of the components in this PC board, and I couldn't find any faulty component, but I did found that these two resistors in here, they have a cracked solder in them. So yeah, I reflow all of the resistors and all of the SND parts with a fresh solder, and I believe this PC board, it is ready to be plugged in to the power and see if it is going to work right or not. So here is my test power cable, and I'm going just to connect it like so. There we go. It's really hard to do it with one hand, but here we go. We did it. And here is my test. Power cable has been connected to the power leads, to the power traces, and here we go. I already plugged in, and as we can see, we have a reflection on the table from the LED, and apparently we have a green LED. It is lighting up, so that is really good indication that this charger, it is probably working. So let me turn on my DMM and connect my negative probe and see the output. And yes, indeed, we have 10 volts like in the Sony, and in the output we have 8.4 or 8.5 volts, and that is really good. And according to the specs that it is written in the label, if we take a look in here, we can see that it is written 8.4 volts in here. So yeah, so the charger, it is now working like it should be, and apparently we have a working charger. So let me reinstall and reassemble the entire thing, because my work here, it is done, and these two sets are ready to be delivered to the owner. So in the end, I hope you enjoyed this video. If you did, please like, subscribe. Thank you for watching. See you next time.